Okay, good afternoon. The red light has come on, indicating that we're now in session. Could you all take turns in giving me a two-digit number between 10 and 99? So a two-digit number between 10 and 99. I'll ask you. Yeah, sorry? 81. And my pen doesn't work. A gentleman behind him? 73. And the gentleman there? 61. The gentleman sitting all by himself? Yeah, you. Two-digit number? Yeah. 59. Yes, someone else have a two-digit number for me? 53, wow. Anyone else? Yeah. Yeah. 11. Yeah? Okay, let's ask some of the ladies. Ladies? 23. Another lady? 34. Sorry, 36? 1, 2, 3, 4. One. Another? 14. Okay, let's go back to the middle section. The 4 people sitting together, give me 4 numbers. 66. And, sorry, 50. 25. Anyone else? 11. Anyone else? Give me a number. Oh, just don't think about it. Just give me a number. 74. And 3 ladies, 2 ladies at the back, at the very back. Let's get you involved. 44. 31. And then give me lady at the back there in the middle. 21. I need 2 more numbers. 13. And 53. Thank you. That's all I need. So now I have, in 2 columns, I have 20. That is 10 digits each. And by the way, I'm Joseph Thomas Panikolankara. I'm your instructor for this class on correlation and regression. And we're going to have fun today. Now, I'm starting off with Excel. The reason that we use SPSS is that IBM, who owns SPSS, gives it to us at a discount. And the reason that they give educational institutions a discount on SPSS is once the educational institutions get students used to using SPSS, then the students will go out on their jobs and they'll ask for SPSS in the companies they work for, and the companies they work for will pay full price, so they won't pay a subsidized price. So IBM in the end makes a profit in some respect, quite a respectable profit, because IBM is in the business of making money. I personally think that IBM is making too much money. It's bad for them. They won't know what to do with that money. They get confused. So I want to avoid that. So I'm going to introduce you to Excel and how you can, because you'll all, even if you don't have SPSS on your desktop computers at where you work, you will have Excel. And it is possible to use Excel for data analysis, for statistics. So Excel, to action this, you click on File, and then you go to Options. Right? From Options, you go to Add-ins, and then Add-ins will get you into another submenu. These are all the things that you've paid for on your computers, but which you haven't actioned, which you haven't made active. So I need Analysis Toolpack. I also occasionally I use Solver, which is a good thing if you're using constrained optimization. But Analysis Toolpack is the one I'm going to use right now. So I say go to Excel Add-ins, and I make a tick mark on Analysis Toolpack. Notice Solver add-in is there as well. We won't do that. And once I do that, if I go to Data, and this is trying to be helpful, you have this Data Analysis tool. And Data Analysis tool will give you the things that we're going to talk about today, correlation and regression. Yeah? But for now, let's enter the data that you've just given me. So first you said 81, then you said 73. I should have thought about this before I think. This will take some time. 59, 53. In fact, I could probably, if I make mistakes, it doesn't matter because these are just supposed to be random data. Some of you who called out numbers will recognize some of the numbers that you called out. Hopefully, you call out your favorite numbers, although you may not have favorite numbers. 50, 25, 11, 74, 44, 31, 21, 13, and last was 53. So, do you think these two columns of numbers are related? Let's find out if they are. So I click on Data Analysis, I click on Correlation, and they ask me where I'm going to find the numbers, the data to work with. I highlight this, and then group by columns. Yes, it is group by columns. Output range, I'm going to have it put here. And I'm ready. 0.19569, almost 0.20 is the correlation. That is a low correlation, but it was by accident. Right? That is one thing you need to remember. When you write your dissertation, remember this. You will get correlations by accident. If you, in your paper, in your dissertation paper, you say that I predicted that this correlation would occur, and it does occur, we got a correlation of almost 0.2 just by accident, right? And that is what happens with correlation. It's not a tool that you can use to justify or to establish support for a hypothesis. It is a very random kind of thing. If I change some of these numbers, like we had 81, 66, so these numbers each, they look at the relation. One thing you can say is 0.19569 is positive. So you can say that as the numbers in column 1 go up, so do the numbers in column 2, because it's a positive thing. Correlation depends, it's plus 1 to minus 1. Minus 1 is perfectly negatively correlated. Plus 1 is perfectly positively correlated. That is, if one number goes up, other number goes up. Negative correlation is if one number goes up, the other number goes down. Right? The other columns. So if I change, like, let's say I change this to, instead of 53, I change this to 13, and I change this to maybe 35, and let's try and do the same thing and see if we get a different result. The only thing that I change now is I'm going to put it here where there's not, it doesn't interfere with what's been done before, and then it's gone up to 0.41994. Can you see it? Oh, does this need to be blown up? I guess so. View, sheet view, column view, zoom to selection. I changed two numbers. There was a 53 in the last number. Instead of that, I made it 13. There was another number, I forget what it was, I made it 35 in the second column. But from 0.19569, I made it now 0.41994. Right? All by accident. Correlation is not sufficient proof, sufficient evidence that a relationship exists between two sets of numbers. It can happen just by accident. Now, in your dissertation, you have to write the justification for why these two sets of numbers will have a relationship, right? Unless you have that, unless there is a theoretical background for assuming that, unless you have empirical evidence, that is a correlation coefficient, both together will enable you to write a dissertation which can be defended and which you can justify. So this is a little example. I'm surprised. This actually, according to Palant, this is a respectable correlation and something you can talk about. But unless the people I asked for numbers and the people and my own two numbers, unless they were somehow in collaboration, there's no reason why these two numbers should have a relationship. Okay? So let's move to our class slides. Today I have just about 30 slides, right? I also have another